Okay, this is number 17 on page 521, and I'm supposed to take this series and write it in sigma notation. So we'll look at this term 1, 2, 3, 4, etc., and then I get up to some term. I don't know what numbered term that is. But it appears that these numbers starting with 1 are doubling, so that this looks like I'm multiplying by 2, so that I've got a geometric sequence. And so in a geometric sequence, I want to know first term, and the common ratio looks to be 2. And so then I'll use the general term formula to find that any term in a geometric sequence can be found by taking the first term and raising it, or multiplying it by the common ratio, n minus 1 times. So in this case, I would say that the nth term will be equal to the first term of 1 times 2 to the n minus 1. So that is just, the 1 is invisible, so 2 to the n minus 1. So when I write this in sigma notation, that can be my general term. And then because the first term, term 1, if I want to put that as 2 to the n minus 1, I say, okay, well, the first term is 1. So this is 2 to the 0, right? 1 is 2 to the 0 power. So n must be equal to 1 if I start here, because this 0 equals n minus 1. So I'll start counting at 1. And this 64 will be the nth term, so that's got to be 2 to the n minus 1. So 64 is 2 to the n minus 1. 64 is 2 to the 6th. So then I know 6 must equal n minus 1. So n must equal 7. So this says go from 1 to 7. So that would be 2 times 2 to the 7 minus 1, or 2 to the 6th would get me that 64. So that would be the general term formula. Another way that you could adjust this, if you didn't want to do this as n minus 1, you just wanted it to be 2 to the n, is start this at 0, start the counter at 0, and then it's 2 to the n, because the first term would be 2 to the 0, which is 1. And it would go 0 to 6. 2 to the 6th would be the last term. So either of these can be used if you don't want to use the n minus 1 here. So those are both just, they both get to the same series. And that's it.